So these are cumulus clouds. And I have to say, for the West Coast, these are relatively rare, especially right along the coast. In other parts of the country, they are quite common. Now, the first thing you need to know to understand what's going on here is that hot air rises. So what we got is the sun shines pretty much unperturbed, going right through the air until it hits the ground. At that point, all that sunlight is absorbed and starts heating the ground. The ground in turn then heats the air that's most touching it right there at the ground level. And as that air gets hotter, it also decreases in pressure because it increases in volume. So the hot air gets lighter than the surrounding air and starts to travel up. Now, as it travels up, it takes with it the moisture that's in the air. Now, it rained last night and the ground is fairly damp and has been so all day. So there's quite a bit of moisture in the air right now, and it travels up with the hot rising air. Now, for those of you who have gone up into the mountains from the lowlands, you know that the air gets thinner the higher you go. And a lot of times when you get to the mountains, you go like, oh my God, I can hardly breathe because the air is so thin. And that phenomena has an important role to play in this cloud development, because it's our thermal, that column of hot rising air that we've generated on the ground, goes up. It meets thinner air. As it meets the thinner air, the thermal itself expands. The expansion of the thermal causes cooling, and therefore our thermal starts to get colder and colder the higher it goes. Now remember, the only reason it's going up is because it's surrounded by cooler air. If at any point it cools enough so it's at the same temperature as the surrounding air, it's not going to go up anymore. Which brings us to yet another point we need to understand what's going on, and that's as we go up in altitude, the air gets cooler and cooler. That's called the lapse rate, and typically, 2 to 3 degrees every 1,000 feet, the air gets cooler. So what has to happen is, as our hot column of air travels up and expands and cools, it's got to nonetheless stay warmer than the cooling of the air that happens through the lapse rate. Now, if you're starting to get confused already, that's okay, because I have thrown a lot of stuff at you. But the next time you yell at the weathermen and go like, oh, how come they didn't predict everything exactly? Just remember, even a simple phenomena like this cloud formation can get pretty confusing in a big hurry. So, sun warms the ground, ground warms the air gets hot, hot air rises, hot air expands as it goes up into the thinner air, but the lapse rate, if it's high enough, means that the thermal continues to stay warmer than the surrounding air. Now, we get to a magical point here. And of course, because this is science and not magic, it's really a scientifical point, is you see this dark bottom here of these clouds, which is actually getting pretty darn dark. That is the point where the air is now cooled enough so that the water that's been taken up in our hot thermal now goes from a gas into drops of liquid. And that forms our cloud. And there we go. We have a cumulus cloud. Now, there's a point in particular that I want to make for paraglider pilots, is that there is only so much water even a huge cloud can hold in it. And when it holds too much moisture, it falls back down again, and we have rain. How do we know that it might rain? Well, the more saturated the cloud becomes with water, the less light goes through it and the darker looking it gets. And if you look at these clouds, they look pretty darn dark. So these clouds are really significantly saturated with water at this point. Now, if you are a paraglider pilot, you might go like, hey, if there's thermals, that means there's rising hot air. If there's rising hot air, I can get in that like a bird and turn around in circles and go up, and that would be fantastic. So the formation of clouds may say to you. For instance, if we look at a big old fluffy cloud like that, we go like, hey, maybe I can go flying. Okay, and that would be a good idea. I need to point out that at a certain point, kind of the point we've already reached here, it becomes a bad idea because the cloud gets too big and too energetic and too powerful. And the general rule of thumb is when these clouds get dark and saturated, that's a sign that it might start raining. And when the rain falls out from beneath the cloud and hits the ground, not only is water falling out of that cloud, but we also have the air that was in that cloud falls down. And that means we can have gust fronts because we're talking about gazillions of tons of air falling a few thousand feet, hitting the ground, and then it's kind of rolling around the ground in this very turbulent pattern. So that can be very dangerous for us. But there's another phenomena that goes on that's going to be a little bit harder to explain. But remember this water gas that we had? So when you go from a gas to a liquid, the change is about 1,000 times. So for instance, the gas, if it took up this much space, whatever space that is, when it turns into a liquid, it only takes up 1/1000th of that space in the cloud. So in other words, you get this gas of a very high volume turning into a water droplet of a very low volume. This means that these clouds themselves start to form vacuums inside them. And when that happens, then the cloud can form really rapidly because that vacuum, just like a vacuum cleaner, can start sucking air up into it very quickly. And that's why people say, oh, there was this freak storm that just came out of nowhere. It's really not the case. That cloud that rains on you that appears to come out of nowhere probably took hours and hours and hours to develop. But that last little bit, when it turns into a vacuum cleaner, means that it starts forming very, very quickly. You notice like this cloud, since the last time we looked at it, is gotten taller than it was before. And here's the thing, that vacuum cleaner effect, the storm engine that happens when a cumulus cloud starts sucking air into it, can be extremely powerful. If we get a big cloud system, big storm system, say, we'll see in the plains of the Rocky Mountains east of, say, Denver, we can get upward airflow of 150 miles an hour inside a major thunderstorm. And let me tell you, your wimpy little paraglider, which is a low energy craft, cannot deal with that kind of energy. So here's the thing about clouds. When they're teeny little fluffy things, then you go, yay, it's marking a thermal for me, let's go flying. When it starts to get to these big things, and they got dark bottoms, you should not only be on the ground at this point, but you should be already packed up with your glider in your bag. See ya!